Welcome everyone to the IATL. We live today, myself, Peter Ashley. I'm sitting here with Emily Stanecki, and we are doing the IMSA presentation today, which is going to be on a connected vehicle landscape and discover the power of connected vehicle technology. We're going to go ahead and go through a whole bunch of different things in this presentation. We're going to try and make it as interactive as possible. So please, if you have any questions, put them into the chat bar. We're going to try to answer questions as we go through. There's going to be some videos. There's going to be some presentations. So I hope we keep everyone entertained enough, and look forward to presenting all this cool technology to everyone here. So we're going to go to...
Thanks Pete, and thanks IMSA for having us today. We're excited to be here. We've got a lot of content to cover, as Peter mentioned, so I just want to give you a little outline of all of the things we're going to be talking about. So we're going to start with some smart city technology. We're going to look at the city of Baton Rouge, and Peter will talk about kind of some examples and details there. We're going to address kind of where we are at, the IATL, and how this has been instrumental in progressing connected vehicle technology. We're going to look at 3 different connected vehicle applications. So emergency vehicle preemption, pedestrian safety in school zones, TravelSafely smartphone applications, so that CV2X network, and then really have Peter address kind of the difference in that in CV2X direct versus network. I think that kind of gives us an outline of where we're going, but I think, Peter, you want to start with an example, Baton Rouge, and what all they're doing there and kind of how they accomplish this.
Yeah, thanks so much. So as you guys are going to see, we're going to have some slides. We're going to go show some videos and things like that as well as part of this whole presentation. The first project we wanted to talk about was one of these cities that's implemented connected vehicle technology on a wide scale. So, in terms of, how did they do it? What did they do? What's the process? How did they get their money as well to actually deploy this technology? So we're going to jump in here and have a look. This is the city of Baton Rouge. And what they did was they first deployed emergency vehicle preemption using connected vehicle technology at 480 traffic signals and 100 odd vehicles there. And after they had done that, they actually went in and did school safety. So putting in the school beacons to turn the beacons on, turn them off, and find out if there are any faults, so remote connectivity to that. Once they deployed all of that, they started to actually go ahead and put in the actual TravelSafely, the connected vehicle aspect, so that they could get some of that information back to the public. So it was just an additional feature that they added onto it at no additional costs or anything like that to the city. But it gave another layer of safety and another layer of benefits to the people there. So, how did they go and get some of the funding? So, they used the Move BR movement, which actually they used state, local, and federal funding, which they utilized to deploy their emergency vehicles. And, if you guys want to know a little bit more about that, we can put you in contact with the right people on how they went out to go get their funding. And the whole idea behind the funding was to support transportation and infrastructure improvements, and to address areas that affected congestion issues. The congestion issues they were looking at were for the emergency vehicles. So obviously on the emergency vehicle side, they were showing that they were going to provide faster response times. And then of course, making the streets safer for the pedestrians. So what they did was, create a pedestrian crosswalk system that they knew as soon as there was any kind of issue, a power failure event or anything like that, they could go ahead and respond to that very quickly and ensure that the school zones were turning on at the right times. And then, so what I'm going to do is, instead of me explaining what they did, is I'm going to go in, actually I've got a couple of screenshots here, but then I'll show you an actual video of what they actually did there. So this is what 480 traffic signals and school zones looks like. They've got traffic signals pretty much connected throughout the whole city, and school zones everywhere. And you'll see the emergency vehicles down here, the traffic signals, the school zones. So kind of everything is located over here for them. Now, the interesting thing was, I'm sure some of you remember when Hurricane Ida came through. And so I managed to jump onto their system and saw what it looked like when you actually have a major event come through that had all these power failures. You see all these red rings around here. These are all traffic signals that had power failures. But you'll see there were actually a couple over here. I mean, it's crazy how the power failure events happened around that. But there are certain ones that actually come back online. But this allowed them to go and find out exactly where they needed to go to during that event for the stragglers that didn't come back online. So it was a great tool for them in terms of getting the network back online when they had all the flooding and everything went down within Baton Rouge. So what I'm going to do now is I'm going to jump into a video that's going to show exactly what they did in their own words. So I'm going to hit play on this and see how this comes up for you guys.
Our parish is unique because of its people. We have people from all over the world, but we still have our Louisiana culture that makes us Baton Rouge.
East Baton Rouge Parish is a transportation hub for a variety of places, including on the Mississippi River, where we have ships and ports, but also shipping from all over the country along I-10 and I-12 corridor.
For a city of our size, we're unique in the way that we approach new technologies, and we're always looking out for new and better systems and better ways to service the public and bring every little bit of efficiency out of the traffic signals and the systems that we have.
Well, since getting the cellular communications as part of the AI platform, we have been able to communicate with almost our entire signal system. That has changed the game for us in a lot of ways. One of the ways is that when there is an issue, we can respond rapidly.
Our new system communicates quickly to us, and we're able to change things as we need to. Sometimes children get out of school early, maybe because of weather or emergencies, and we're able to change that system as we need to.
We can fix problems from here on demand.
When we first saw it, it was literally just a black box. It was like, you could do all kinds of things with this black box. Then it's grown into this great product that we are so happy to have.
We had help from AI and Temple, extensive help from Temple with the installation process, and AI was constantly available to help us configure the devices.
It's very important to the Baton Rouge Fire Department. We've got that preemption system that allows the traffic signals to change to green in order for us to better make it through the intersection more safely and get us to the cause quicker.
Technology is extremely important, especially when we think about emergency situations. And with the implementation of light synchronization, our EMS vehicles, fire trucks, law enforcement can easily go through a light when needed when it's an emergency, and it helps expedite the situation.
It allows us to include and work on connected vehicles. As connected vehicles become more prevalent, this has created a way that we can cater to that need, and it's all of just a part of the AI platform.
We like the connected vehicle feature because it lets the public know that we've got a truck that's en route to a call on a particular route that we're on, so they're on the lookout for it.
We've always been interested in looking towards the future and trying to prepare for all of the new technological advances that are coming. We're in a golden age of new advances.
I've been around a long time, 35 years working with the city, and it's amazing to me what transition is taking place in technology. Certainly I believe it's going to be a big plus to us, but more importantly for the citizens. I look forward to the challenges and the pluses that we're going to have in the future.
always really cool to hear from the actual, users of these systems. So seeing that connected vehicle technology working today, and we're going to talk about, the EVP portion of this, but something that gets so overlooked oftentimes is just the remote communications benefit, that these cities are receiving from utilizing this technology with everything being connected.
Yeah, absolutely. That was one of the things that they discussed in the video there, which was they had about 230 of their intersections were on fiber, but another 230 or 240 weren't on fiber. So they utilized the same technology that they put in for connected vehicles and getting the emergency vehicles through to actually connect it to their ATMS.now application. So they got communications, and it looks like any other intersection, just running over the cell network versus over the fiber.
Yeah.
So they kind of killed two birds with one stone, which was pretty nice for them.
Yeah. Let's pop over to, I think, talking a little bit about the Infrastructure Automotive Technology Laboratory. So we abbreviate this to the IATL. You'll hear us say that often. But, this was a space that was instrumental in bringing connected vehicle applications to life. So it's a private-led, private sector-led, development. Not only do we have all of the technology here to test every single, intersection controller that's in the United States is located here. It's a space we wanted to create where people can come and train and learn, and it was really built to bring people like the automobile makers, to bring cities and agencies, to bring traffic engineers to one location to see how this all interacts together. So not only do we have the lab, which you're seeing behind us, and we'll look at little bits and pieces of that through some of the upcoming video, we've got 120 connected intersections just outside this building. So we can see it in real life and experience it.
And that really gives the car manufacturers the ability of testing something here in the lab where, we're in the city of Houston where they're using traffic aware controllers, and right next door in Harris County, they're using Econolite software. So they're able to then, because each one of these sends out a slightly different message. Right. It's not exactly the same. So they can test it here locally on the desk, run it on their vehicles outside, and then go run around in traffic. So this was the idea of trying to spearhead getting that connected vehicle technology out the door a little bit quicker with these car manufacturers, for them to have a place where all this different infrastructure is actually deployed.
Yeah, we call it truly a dynamic testing environment, and we would invite anybody who's interested, the doors are always open, so whether you can make it in person or we need to do a one-on-one Zoom, but we'd love to have you guys more involved and integrated into what we're doing here. So feel free to give us a call or chat us your contact, and we'll be glad to get you here. So
that's a good point. In other words, if anyone, what's quite special that we like to do is anyone that's on the call, if you want to set up a one-on-one meeting with us, love to do that, where we can go through what's within your city, and then we can basically connect it up in the background here and do that directly for you. So the first, we're going to show another little video, which is how the IATL came to be. We shot this actually just before ITS America, so we are playing a video that we shot beforehand. And it's going to explain how the lab came to be, and then also looking at the first application that we talked about, which was emergency vehicle preemption using connected vehicle technology.
Get ready for green.
Welcome ITS America to the Infrastructure Automotive Technology Laboratory. I'm Emily Stanecki, and I'll be your guide through the world of connected vehicle technology. We're sitting here in the lab where we're dedicated to making connected vehicles work not only today, but for our future. The IATL is the first facility where automakers and the transportation infrastructure are working together to accelerate the advancement of connected vehicle applications. Located in Alpharetta, Georgia, the IATL is equipped with every traffic controller in use in the United States today. Surrounding the IATL is a real-world connected vehicle environment on the streets of Alpharetta with more than 150 connected traffic signals, including CV2X. Connected vehicle applications being shown are emergency vehicle preemption, school zone and school bus safety, and the TravelSafely connected vehicle smartphone app. Now let's take a look at some of these applications in real life today. Everybody likes green lights, but what if they could also save lives? We're using connected vehicle technology to get emergency responders to the scene more quickly and more safely. Let's take a look at just how we're doing that.
The traffic preemption system here in Alpharetta has been installed on all of our traffic lights here locally and on all of our fire apparatus. We have a transmitter on our apparatus which allows us to basically get a green light as we're responding on incidents throughout the city. The preemption system changes the light directly in front of them, but it also starts staging the other lights ahead of them so that traffic flows better. We've transitioned from an older system that was infrared or line of sight to a newer system that's GPS based, and it seems to be working great. When you're gaining 10 to 12 seconds per traffic light on average, it really has an impact on the response time.
In a fire situation, 1 minute, the fire can spread throughout the rest of the building, whereas if we got there 90 seconds faster, we can contain it into a smaller portion of the house, cause less damage, less risk of life and injury and property. So when we turn the truck on, it usually takes us 10 to 15 seconds to get right to this light over here. And like I said earlier, it's a very busy road, Newport Ave, kind of goes all throughout Quincy from the one highway exit to the next. And like I said, it's really hard for anyone coming north or south to see us coming out of this way. Even if our sirens are on, these walls kind of block the noise. So if the red light is there for them, then we don't have to be too concerned. We always have to stop because people are known to run red lights, but it is safer just to have the system making sure that we can make that turn.
Yeah, the first year it has been a huge improvement from where we were at, the system we were using. In the old system, part of our time was taken up every month. We would have to go do checks on the equipment and go look at it, and the fire department did that on top of the streets looking at their end. So that took up time for us. Getting out in the traffic trying to do that took up time. Now we have the ability that traffic department, streets can look at the system and say everything's good, or they can call us to say, hey, we're seeing something. Have you guys noticed that you're having a problem at this intersection? So that's working great. Noticing that the calls, when they're going on calls now, that they can watch the lights change out in front of them. In the past, you had to be in a certain distance and line of sight to see that light change. Now it doesn't matter if you have traffic in front of you. If you're within that distance, the light's going to change. So no news is good news. When the crews aren't calling you to have a complaint on something, it's working good.
We've all got those intersections that we get to that are high traffic. Doesn't matter what time of day it is, it's high traffic. So what we can do is work with AI to build these customized paths, if you will, to allow that traffic to get clear. So, we might get there in the light screen, but if we have traffic, we can dig into the data, understand, okay, if we go to this traffic, 75% of the time, we know we're gonna hit the next two intersections. Well, let's go ahead and clear those out beforehand. And so when we're getting there, that traffic, not only do we control the intersection, but the traffic's gone. By saving the time that we have, we're able to, you can look at it in the cost savings of, okay, if we need to put another fire station over here because of our response times, but now that we're able to, with the preemption system, cut those down, we don't necessarily need that fire station. And so we've looked at it kind of quantitatively that way as well from the city side, that, you pretty much spend whatever you want to on a fire station, but, we're talking, let's just say $5 million for a fire station. Well, we're saving that money because we can meet those standards, the response standards now, because the preemption system has allowed us that time savings, and it's only getting better as we continue to optimize the system.
So, you can see there that the connected vehicle technology, and I always like to show emergency vehicle preemption as the first one because it has such an impact.
Right.
And you are saving time, you're saving seconds, and that's just really, really important for the technology out there, that we can actually go out and save that time. So that's one of those things that utilizing the radios to communicate direct, utilizing the GPS position of the vehicle, and utilizing cellular communication really changes the way that you can do emergency vehicle preemption from the old school style of just the infrared communication, the optical communication side. Now you can really get those further distances away. You can turn around the corner, so you can prepare all of these signals, which is fantastic. So that gives us some pretty cool technology that's actually out there. And I've got a couple of little points over here that I was going to talk about on the presentation. So, I think my presentation for some reason has stopped. Let me go get this back up and running here.
I think the title of the next slide is why EVP is important, and we heard from not just one fire department in that video, but they were from all over the country utilizing this technology, just toting how important it is and the improvements that it's made for them in safety. And we've got some statistics and things that, Peter, you'll cover. So
yeah, so I mean,
it's critical.
With the city of Alpharetta, they basically showed an 18% drop in response times going from an optical solution to a GPS-based connected vehicle preemption system. They're basically seeing an average of 10 to 12 seconds saved per traffic signal. People like Marietta have seen about a 30 to 35% improvement in response times. So it all just depends, in terms of what you've had beforehand to what you have now. So, if you're going from nothing to preemption, you're going to see a huge amount of savings. And the cool thing with the preemption system, when you're doing a connected vehicle preemption system, it's not like the old optical where only one party's getting a benefit. When you're putting in preemption now, the traffic department gets a benefit. They get remote communications to all the traffic signals. They get notifications of power failures. So there's a real benefit to the traffic department, plus the connected vehicles over the smartphone app that we'll see later. So there's benefits for all the parties involved versus just one party. So that's one of those big steps that we've done. Very important is we increasing driver safety. So, the emergency vehicles receive green lights ahead of the time so that they don't have to worry about, having traffic in front of them, jumping lanes. It just, becomes a lot safer for them. And, what we're doing as well is because we're using this dual mode communication of both radio and cellular communication, that allows the vehicles to send the signal way in advance. So, if you're looking here, you can actually send it to this traffic light, but through the cellular network, we can also send it to the traffic light here, the traffic light here. So if there's congestion ahead, we can make this light go green and this light go green ahead of time to flush out all that traffic. That gives a much better preemption system. And at the same time, because we're doing second by second communication, as soon as the vehicle is 30 feet past the signal here, it puts it into normal operation. So gone are the days of, when you had optical where you would wait 15 seconds as the vehicle's gone through before it gives the control of the signal back to the traffic controller. This does it immediately. As soon as that vehicle's passed, you're immediately going to get the control back to the traffic controller. And what's more is actually we've implemented a whole bunch of new protocols like NTCIP 1211 that you can actually keep your traffic controllers in coordination because we're sending the signal 90 seconds in advance to that traffic cabinet and to the traffic controller, so it can adjust in real time to that emergency vehicle approaching and keep that controller in coordination with all the other controllers. So preemption is becoming very, very real in terms of not actually affecting traffic very badly at all. And if you talk to a lot of chiefs, they'll actually say, well, getting all the other traffic splitting across the roads and all the rest, that causes more mayhem than just getting a green light quickly for an emergency vehicle. So I'm going to go see if I can get to this next slide here. Emily, do you want to? We're going to move over to school zones. Do you want to talk a little bit about that?
Yeah, sure. So I think our next application that we want to focus on is improving the pedestrian safety in school zones. This one's near and dear to my heart, especially as a mother of a young child, as you know, Peter, I mean, same thing, father of young children. So, you know, safety is really at the core of what we're trying to accomplish, utilizing connected vehicle technology. And we've got a couple of statistics that we'll talk through. You know, it's staggering. It's, 25,000 children are injured in school zones every year. That feels like something that we can improve. So that's what we're really, you know, working towards with this school safety programs. 2/3 of drivers speed in school zones, or even maybe not even aware that they're in a school zone. You know, when we have flashing beacons, it can reduce driver behavior speed up to 5 to 7 miles per hour, which is critical. I think the other statistic we have, I don't know if we have it on our slide, but when there's that reduction in speed, the chances of saving the life of somebody hit by a moving vehicle then increases. So
yeah, if someone's driving less than 20 miles an hour, there's a 90% chance that the pedestrian's going to survive.
Critical.
And then it drops 10 miles faster, it drops down to 50%.
Yeah.
Another 10 miles, it drops down to 10%.
Yeah.
So, you know, those numbers are staggering.
Yeah, staggering and critical. So why smart school beacons? This is a great platform that we have, connected school beacons. So Peter, why connected school beacons?
Yeah, great point. So, you know, obviously there's the basic functions in terms of doing remote scheduling, you know, where you don't have to go and punch in anything on a time clock in the field. It's all done straight from your smartphone or from a tablet that you can actually go in and program those. That also allows you to keep the beacons on at the same time as well. So if there's a snow day or something like that, you can cancel the beacons so that they don't turn on at the wrong times. And you've got alarms and alerts that you can provide whenever there's any kind of failure, so you can fix these things a lot faster. And you know, we actually have advanced reports and things like that that look at the battery health, the solar health, so you can see that a tree's starting to grow over or something like that. So all those kinds of things are really important. And then adding to that is the connected vehicle aspect. So we're going to play another video which is all around school safety and also how we've worked with some of the auto manufacturers to actually implement this directly in the cars. So we're going to play this video and you guys can have a look at that and then see sort of, you know, in terms of what we're doing to improve school safety with turning the clocks on at the correct time, but then also at the same time, how we're building this into the cars.
So that was a look at how we're using Preemption connected vehicle technology. Now we're going to look at how we're using that same technology to keep school kids safer.
When COVID happened, school signals and monitoring them became huge. Right? In the past, people said, no, my school schedule never changes. All of a sudden, their schedules were changing almost on a daily basis. They were missing most of their staff. And we were able to basically accommodate them by updating schedules, by telling them what was working, by turning their school zones off and on. At the same time as we came out of COVID, we had just done a large project with driver feedback radars. And what we were seeing is, of course, everybody got back in their car like the day they turned 16. They're all speeding, they're driving like crazy. And we were able to use that with an early adopter customer who did that to say, hey, here's a real problem. Schools reopened and guys are going 50 miles an hour through the 15-mile-an-hour zone. We were really able to, we think, to help them, you know, get a handle on that, to understand how bad their problem really was. We're getting to them in advance and making their lives a lot easier and making things a lot safer at the same time, which is ultimately our goal, just keeping everybody safe.
I find that a lot of municipalities will spend several tens of thousands of dollars for these school beacons and put a 20-year-old technology push-button dial clock that's in there. And it's 20 years old. It's going to be 40 years old when they need to replace this thing again. So To use technology to make the school beacons work really the way they're intended to. The start-stop times, the 2-hour delays, the cancellations. I come across too many school districts and townships that flip them on in September, flip them off in June, and that's it. And that's not really how they're designed to work. Now with technology, we can use this right on our phone or our iPad and instantly make those changes to make these beacons work the way that they should work.
You log into Glance and you pick the device that you want to manage. All the programming is there. I literally could change a whole school district worth of start and stop times or days off with about 3 minutes worth of work. It's just an incredible tool.
We're using applied information's technology that they have. We've deployed it on one bus here in the city of Alpharetta, and they're using it to help develop the possibility of notifications to motorists before they might even become in sight contact of a school bus that's loading students. You know, we had the knowledge of how a school bus operated. We knew exactly what needed to transpire, where things needed to be hooked up. So we took our technicians and worked with Applied's technician, and it was a quick install. It didn't take much just to get the pilot underway. It's extremely exciting. The possibilities of what this can do and what it already does, it's mind-boggling sometimes. Anywhere that we can gain and put ourselves out there and help develop what might be coming down the road, I think is a benefit for everyone.
This is really important because for now, the school children are probably one of the worst affected vulnerable road user category, with almost 25,000 injuries and 100 fatalities a year. Audi is committed to using technology to not only protect customers and drivers in our cars in the event of a collision or incidents around the road, but also to avoid these types of incidents altogether. And we do this first through alerts that are visual or audible inside the vehicle so drivers can react to that. But we also think that the same CV2X technology in the future could be used to create automatic maneuvers that the vehicles could take to prevent these types of issues if the driver so chooses or is unable to react. And of course, in the future, we see this as a crucial part of the roadmap towards automated vehicles, which will be able to manage many different types of situations on the road on their own.
Great. You know, those are, I mean, whenever you see that kind of technology in action, you know, that's a fantastic thing to see. Obviously, there's the one aspect of managing your school zones, but, you know, as we're talking about the connected vehicle technology, getting these devices out there and getting it on people's smartphones,
right,
and getting it in the vehicles,
actually in the vehicle,
is what we're trying to do here.
Right. I know you're going to talk more in detail about the pilot project that was mentioned there, but you know, the direct communications to the vehicles from the school bus. We talk about our school beacons and school zone safety, but this is a whole nother level of connected vehicle technology that we're actually talking about today. So it's pretty cool, pretty exciting. It's not the future anymore. It's here. So.
Yeah, and this is a great thing. This is why we've been progressing this technology. It's really important for us. And you know, it's also important for the car manufacturers,
right?
Because it's not just about traffic signals. You know, the one thing that everybody always talks about traffic signals for connected vehicle technology. The easiest place for us to actually go and equip this technology is in school zones.
Right.
It's much cheaper to do that than the traffic signals. Far less complicated for the car manufacturers. And you know, I mean, we're really going to save a number of lives instantly with the school areas.
Right.
So it's one of those areas that you know, people like Audi are really focusing on quite a lot, and Ford and you know, many other car manufacturers that are going to be bringing out this technology.
Right.
So we're going to have a look at a couple of the statistics here. So you know, basically the pilot project here in Alpharetta, which they're going to be expanding, was basically to alert drivers entering an active school zone and warning them when they're speeding. The way that works is, what we do is only when the beacons are on do we tell someone they're in a school zone, and they only get that ting alert that you saw in the video there when they're driving more than 5 miles above the speed limit. So that's a key aspect behind there. It's only when they're 5 miles above the speed limit and they're in an active school zone. If they're driving in there normally, you're not going to receive anything. The second alert that you're seeing in the screen down here at the bottom is the alert of when the stop bar arm is open. So I mean, you heard there's 80,000 violations per day in the United States. 80,000. So, you know, the idea is that we can actually, and most of the times people just don't realize it. They're on the other side of the road, they don't see the school bus stopping. This will provide an additional layer of safety, both via smartphone apps and via in-vehicle notifications. So, you know, it's a sophisticated solution, but it's actually really simple. All you need is a device in the field, in your actual school zone, that we're also doing one with Audi with pedestrian crosswalks and things like that. So all of those kind of applications are very simple to deploy and really, you know, provide this life-saving technology. Maybe what we're going to do is, you know, in the case of time and all the rest, we want to save some time for questions at the end of this, is we're going to move over to the smartphone application. Emily, maybe you want to take us through a little bit on that.
So we were just kind of focusing on the direct communication and what if you don't have access to a smart car, right? So not everybody's driving the newest, latest, greatest Audis and et cetera, but what we have is connected vehicle technology that can be used, you know, directly on your phone. So we've got an application, TravelSafely smartphone application, that is a true connected vehicle application. It allows you to have that communication when you have these devices in the field communicating to one another. And so Peter will talk a little bit more about the network and the cellular usage of that, but the real goal is to improve the road safety for motorists, you know, cyclists, that's even an application we're utilizing this for, pedestrian, any vulnerable road user. And then even I think about, we're talking about the smart vehicles versus not, you know, my grandfather in his, you know, 40-year-old truck that he's still driving around, if he's got his phone, he can get these same basic safety message alerts directly to his phone, you know, bringing that awareness to what's going on. So it's pretty amazing that you know, we've got this application available right now.
Yeah, and for those of you that are more in the whole connected vehicle side of things, we're using the SAE J2735 message set within the smartphone application. So the same way we send it out over direct communication, we also send it out to the smartphones. And we're sending out SPAT messages, we're sending out basic safety messages from the vehicles. And when the smartphone turns into a pedestrian or cyclist, it's sending out personal safety messages. And a TIMS message is a traveler information message, such as you speeding in a school zone, dynamic message sign enunciations, curve warnings. You know, the application has actually got roughly, I think it's about 26, 27 different applications that are built into it. So it's got a large number of applications that run in it. There's another aspect. We're not trying to monetize the app or anything like that. It was a chicken and egg situation. How do you get people to deploy connected vehicle technology when there's nothing in the cars at the moment? So that's why we developed the app, and we've seen a big, you know, usage of the app. That what we've done is we've opened it up to DOTs as well, and cities. So the city of Dunwoody is building it into their own City of Dunwoody app. The Alabama DOT is building it into their own app. That they already use for traveler information. We're doing the same thing in Texas. So, you know, there's a lot of places we're just opening up the source code for those people that they can put it in there. So we're not closing anyone out. The idea is, how do you advance this? How do you get more people using it? So what I'm going to do is I'm going to show a video that's going to go into, you know, what TravelSafely is and how it works. And then we'll come back and talk a little bit further about that.
This same connected vehicle technology is available for vulnerable road users and motorists on the TravelSafely smartphone app. Let's take a look.
Red light.
TravelSafely, the smartphone application, allows a motorist to directly interface with the traffic controller or the cabinet, receive the signal phasing and timing information. They're seeing the indications at the intersection, but sometimes as you're coming up to an intersection, you don't have a great line of sight to the signal indications. So having that supplementary information in your vehicle, warning you if you're about through a red light.
Red light.
And I think the applications with pedestrian and cyclist safety is going to be game changing. You know, getting pedestrians and bicyclists to use the app, getting vehicle drivers to use the app, and then once that is being used, those interactions will become more transparent. So it just gives the driver or the pedestrian or the cyclist just so much more information that they can make good, safe decisions with.
How the TravelSafely smartphone connected vehicle app complements the feature from Tesla that recognizes traffic signals and alerts you when the signal is changed.
Get ready for green.
TravelSafely will also warn you if you are about to run a red light.
Red light. Speeding in school zone. Speeding in school zone.
So here we're coming up to a signal and we're the second in line. TravelSafely still sees the red light, and so does the Tesla indicator here.
Get ready for green.
And because we were the second car back, the Tesla did not alert us with the ding, but TravelSafely did give us the get ready for green notification. We're coming around the corner. TravelSafely sees that the light is red. And when we come into view, the Tesla sees it also.
This is TravelSafely running in the Ford dashboard.
Get ready for green.
There's the Ford speakers, the Ford dashboard telling you to get ready for green.
Red light.
And there's the Ford dashboard telling you that you're about to run a red light. So this is the TravelSafely in the Ford dashboard in a work zone.
As you can see, we're making connected vehicle technology available today and helping to make a safer commute for all. Thanks for joining us today from the IATL. I'm Emily Stanecki.
So you can see from all of that, you know, the TravelSafely app has been out for over 5 years. We've been developing that and really trying to make connected vehicles reality with all the, you know, everybody has these, you know, everybody has a smartphone already. So you can actually deploy this stuff without waiting for the car manufacturers to come online at the moment. In other words, it's a way of deploying it. So I think that's really important.
And the video showcased so nicely, you got to actually experience those audible and visual alerts, which are critical, and it was side by side in some of these advanced vehicles, such as the Tesla, but the technology is there and available. And Peter, as you were alluding to, really is what's helping us advance the deployment of connected vehicle technology. We've got it there in these, our magic black boxes as we've referenced it, but getting that into the hands of the community is what's really going to progress this. So it's pretty exciting.
And guys, I'm going to be talking a little bit about, as we're talking connected vehicles, what's the difference between, everybody hears the word C-V2X or has heard the word DSRC. What is that? So I'm going to talk about that. But as I'm talking about that, please write down questions. Ask us questions. We've still got some time to answer the questions. I want to keep some time available. So please start asking questions as I go ahead and explain the difference between the two.
Yeah, we'll see them in the chat box. So shoot them in there.
Perfect. So, on CV2X, which is cellular vehicle to everything, there are two forms of communication. There's one which is CV2X direct, which is local radios, 5.9 gigahertz, and that's what dedicated short-range radio was as well, DSRC, but obviously all of that's been ruled out by the FCC. So everything's going over to CV2X, and all the car manufacturers are only putting that in. And
CV2X Direct was the example we saw with the Audi and the school bus, correct?
Exactly.
Right.
So when you saw the Audi going up there, it was using direct communication to those school zones and to the school buses. So what we can do is we can have a look at a diagram here, and I'll show you the differences between the different examples here. So you'll have your traffic cabinet. I've got it as number one. There's a device in there, your traffic signal controller, that we're listening to and we're talking to. And we actually have a little device in there that broadcasts out 4G communication and actually 900 megahertz radio to the emergency vehicles. And then what we've done is, often if anyone's dealt with DSRC, they would have had a radio on top of the pole over here. What we've done is we've actually made it so that you can maintain it. So this is set up at 8 to 10 foot, so you can use a ladder, and you can have the CV2X radios in here, and then the antennas are at the top of the pole. Antennas never break, but the electronics will break. Lightning strikes, whatever it is, or software upgrades, whatever comes out. And what this allows you to do is then a vehicle like the Audi that has an OBU in it will be able to communicate to the radios. And this provides all those applications that we were showing. Same thing in the school zone. And when you're with a smartphone, it will communicate directly to the cabinet over the 4G or 5G network. So this gives you both ways of looking at it. Dedicated short-range radio is DSRC, a short-range radio. This is 5.9 gigahertz. And this is just over the normal 4G or 5G communication. Give you an idea of the architecture behind this a little bit. You'll have vehicles, and often when you've got a dedicated vehicle like a snowplow or whatever, we still use a smartphone as your display, and then that connects via Bluetooth to an OBU, which connects to that radio and to the traffic signal controller. When you're doing it just over cellular, it's communicating just over the cell network directly to the mobile application over here. So you've got all of this information coming in there that makes all of this possible. And I can't spend all the time talking about the background of all of this kind of stuff. If you guys want to go through the behind the scenes, the technical details, we just set up a meeting here. We can walk you through it. We have also been doing a lot of work with consultants as well,
right,
in terms of bringing them on board and get them on board in that fashion.
Yeah, I'm glad to facilitate that in any way we can help. I think we could probably spend an hour on each of these topics alone. So.
All right, Emily, do you want to read the first question to us?
Okay, let me lean in here and see if I can grab these. So the first question we've got, are you concerned that the smartphone app could cause distracted driving?
Absolutely, 100% yes. So, the smartphone app, absolutely, we are concerned, and that's why we designed the app 100% to be audible first. Our app runs in the background. So people will be using Google Maps or whatever other applications they would be using to have that our audible notifications come through. We did do studies with the University of Florida as well that basically showed audible notifications make someone 50% more likely to see a cyclist ahead of them, or they are also more likely to see pedestrians, or their eyes start scanning for pedestrians in a school zone area. So audible first, that's the way that we look at this and how we always would want it to happen. You want to get to the next question from
Sure.
Jeff?
Okay, so Jeff, we've got, are there any applications of transit priority?
Absolutely.
Yes.
So the same way that we do emergency vehicles, we're doing transit priority. So, we put in a vehicle unit into the vehicle, or in the city of Boston or NBTA, we connect it to them via a virtual interface that we can basically put priority calls in to the vehicles.
Right.
To the intersections.
To the intersections. Right.
And that is also done in the same way using, often cases, NTCIP 1211, so we can keep everything coordinated, and we can even do it, when the vehicle's late, or if there's a certain number of passengers on the bus. So absolutely, this same technology will do emergency vehicle preemption, transit signal priority, remote communication to your traffic signal, and also alerts and alarms when power failures and things like that happen.
And all simultaneously, so one technology. Reach out to us, Jeff. We'll love to follow up on that conversation. All right, William, any ideas or plans to connect this technology to a platform such as Google Maps to eliminate the need for additional apps and ensure more widespread use? We get that a lot.
Great question. Great question. So the answer is absolutely yes. The only issue we have is it's all about scale when it comes to those bigger companies. Right. So we're starting to get, we've got about 27,000 deployments of this technology in the United States. But, they're 350,000 traffic signals. So, we do have cities like Baton Rouge and City of Marietta and Alpharetta that are fully connected, but it's difficult to get those bigger people to implement it. So we are in talks with them, Waze as well. They just don't have the ability of doing these applications as yet, but we are getting there slowly through the 5G Automobile Association, where we're bringing it in and pressure over there, where Google and Apple are now part of that.
All right, to the next one, we've got, would the TravelSafely app work if an agency is using SCMS?
Answer is yes and no, and depending. I know I'm very confusing there. So SCMS is a security credential management system. Basically, it's utilizing security certificates to credential, are you a real person there? Smartphones generally don't use those. So the SCMS providers haven't actually designed it for smartphones as of yet. What we've done is we've implemented security certificates that are utilized in the internet right now. So we're actually using SSL certificates there, which are probably a higher encryption, 512K encryption, and they're getting updated all the time, where the SCMS is loaded onto a vehicle for a year, where we're updating it all the time. So the answer is yes and no, because I don't think the SCMS systems are ready for us yet, but we've actually implemented the exact same style of SCMS, just with cellular-based technology with SSL certificates.
All right, awesome. Next question, is there a new version of the equipment that goes in a traffic signal cabinet that would support SDLC connection instead of harness?
Great question. We get that a lot. So what we looked at was SDLC and we looked at Ethernet. And you can do everything over Ethernet that you can do over SDLC. So right now, the areas that we need to wire up, SDLC doesn't give us power. and it doesn't give us some of the other aspects of what we're looking at, like cabinet fan status. So there are a couple of harnesses that we like to wire up because that's not available on SDLC. And then what we do is we put in preemption cores, priority cores, NTCIP 1211, 1203 cores directly over the Ethernet. So we found that to actually be much more successful and much easier to actually implement than SDLC. And if you put SDLC, it's a very expensive connector. So then the prices go up and things like that, where Ethernet is very, very cheap. So that's why we've gone ahead and we've just implemented all those functions that you would normally do over SDLC straight through the Ethernet port.
Next two questions I'll combine. Name of the app, so you can find it on the App Store, so TravelSafely. And the follow-up question, is TravelSafely available widespread or just in limited areas?
So great question. We only are making TravelSafely available in areas where they have equipment deployed, so that it doesn't open up and then somebody just doesn't see anything working. So we got cities like Baton Rouge or City of Cary that are implementing it in every traffic signal, every school zone, every emergency vehicle, every pedestrian crosswalk, every bus. So then it has a real value to them, and then the city next door is putting it in, and the city next door to them is putting it in. So it's getting this sort of wide-scale deployment in those areas that allows cities, and it makes it far more worthwhile for the public to download the app, and also more worthwhile for people like Google and all the rest to start looking at it then.
Awesome. Well, I don't think we have any more questions, so I don't know if, Haley, we need to pop back over to you, but thank you so much for your time today, IMSA, for having us. It's been a pleasure, and as always, any follow-ups you guys would like to have with us here, we're an open door, whether it's virtual or in person. We'd love to have you.
And anyone that wasn't able to attend the meeting, we can send out a link to a copy of the meeting that you can share around as well. So we'll do that in a follow-up email that you guys can share with any colleagues that you would think that this would be of interest. And please reach out to us, sales@appinfoinc.com, if you want to set up any personal meetings, or myself, which is P Ashley, P-A-S-H-L-E-Y, and we'll put it into the chat box here that you can just directly email us and set up some meetings here. We'd love to talk to you. So, Haley, you want to go ahead?
Over to you.
All right. Thank you so much, Peter and Ashley. That was Peter and Emily. That was amazing, and I know that I got some really amazing information. So I hope that you all did, and now have the ability to have a credit and some continuing education credits, and just you will have that contact information for both Peter and Emily. And I know, like they said, they'll reach out with the recording. I know a couple of you who joined late, I mentioned that I would send you the full link, so you will get that as well. And if you have any further questions, reach out to me as well. You can reach me at hmarlowe@imsasafety.org, and I can pass you off to either Peter or Emily. But this was amazing, and I hope you guys enjoyed it as much as I did.
Thank you, everyone.
Thanks, everybody.
Bye-bye.